I talked about reasons why you would want to estimate the economic impact of climate change, and I talked about methods for estimating the economic impact of climate change. Let's look at the results and what is wrong with those results. Here we have the graph again. On the horizontal axis, you're looking at climate change and the extent of climate change. On the vertical axis, you're looking at the severity of climate change as measured by the Higgs equivalence variation. The first thing you notice about this graph is that the initial impacts are positive. We start above 0. The reason for that is threefold. First, if it gets warmer, you need to spend less money on heating your home in winter. You also need to spend more money on cooling your home in winter, but the cost savings are larger than the cost savings in winter are larger than the additional costs in summer. That is the first reason. Second reason is that cold-related deaths will fall if the world gets warmer, whereas heat-related deaths will increase. And in certain parts of the world, the decrease in cold-related deaths is larger, much larger than the increase in heat-related deaths. And in those parts of the world where this happens, people are pretty rich and therefore prepared to pay quite a lot for health risks. And that is the second reason why the initial impacts may be positive. And this falls mostly on rich people. The third reason falls mostly on poor people, and that is CO2 fertilization. There's more CO2 in the atmosphere, and plants grow faster, and this is particularly true in arid and semi-arid areas. And there is a boon to particularly poor people. Now, these initial impacts are irrelevant for policy. The 0 here is pre-industrial times. We are now here, we've seen already 1 degree of warming or so, and actually we're very close to the turning point where incremental impacts start turning negative. And because of the long delays in politics, in the energy system, in the climate system, we can actually only start influencing climate in this part here, only where things have gone decidedly negative. So the initial positive benefits are sunk benefits. We will reap those benefits partly because they're in the past and partly because they're in a part of the future that we essentially are too late to control. We will reap those benefits anyway, and therefore they are sunk benefits, irrelevant for policy. Second thing that you see is that if you move to more pronounced climate change, then things turn negative and turn increasingly negative. The third thing that you notice is that there's actually a lot of disagreement on the details of the impacts. If you look at 2.5 degrees, then the average is 1.3% loss of your equivalent loss of income. Some people say it's slightly positive, other people say it's more like 2.6 degrees. So there's a lot of disagreement. Same if you focus on 3 degrees of warming, there's a lot of disagreement between experts. But at the same time, they all agree on the order of magnitude, that the impact of climate change is measured as a few percent of income. And that may be a surprising conclusion if I give you the context. Because this 2.5 degrees of warming will happen in 50 years or so from now, and then losing 1% of that is essentially saying that a century of climate change is about as bad as losing 1 year of economic growth. And that suggests that climate is not a very big problem. It's not the biggest problem of humankind, unlike some people would like you to believe. If you ask the people in Greece, who lost on average a third of their income due to the Eurozone crisis, would they rather have another Eurozone crisis or climate change? They would probably opt for climate change, because a third of your income in 5 years' time is worse than 1% of your income in 100 years' time, or in 50 years' time. If you ask the people in Syria, would they rather have a devastating civil war or a Eurozone crisis, they would probably say, well, I would have liked to live in Greece through the hardest times, because that is worse than what we have seen in the last 10 years or so. Climate is also probably not the worst environmental problem of humankind. I'll talk about this later, but the projections for the death toll of climate change is something like 1 million people per year in the year 2100. And you would rightfully say, well, 1 million people, 1 million dead is 1 million too many. But that is in the year 2100. But conventional air pollution kills this year, in 2020, somewhere between 7 and 8 million people each year. And I would say that 8 million in 2020 is more than 1 million in the year 2100. So these studies suggest, if these numbers are correct, that climate change is a problem, but it's not the biggest problem or the biggest environmental problem that we have. The final thing that I want to say is that the uncertainty is large. The dotted areas indicate the 70% confidence interval. And the reason that uncertainties are so large is very simple. We're talking about things that happen in a distant future. The uncertainty is also right skewed. That is, the lower bound is much further from the central estimate than the upper bound. Negative surprises are much more likely than positive surprises of the same but opposite magnitude. The reason for this has to do with 3 factors. First has to do with the climate system. If you ask a meteorologist or a climatologist how much would the world warm if the atmospheric concentration of CO2 doubles, then the standard answer that you get is, well, the best guess is around 2.5 degrees, with a range of 1.5 to 4.5. So the upper bound is much further. The upper bound 4.5 is much further from the central estimate 2.5 than the lower bound 1.5. So that is the first reason. The second is that all of these impact functions that drive these estimates are nonlinear. 4 degrees of warming is not twice as bad as 2 degrees of warming, but more like 8 times as bad or 4 times as bad as 2 degrees of warming. So that is the second reason. And many of the impacts that we're talking about are negative and get easily out of hand. Whereas a reduction in cooling costs, yes, that is true, but it cannot get out of hand because that is bounded from how much we currently spend, and you cannot save more than that you currently spend. And there's plenty of stories out there that tell you that climate change is going to be a disaster. There's no stories out there that tell you that climate change, because of climate change, we will all be blissfully happy. And for those reasons, negative surprises are much more likely than positive surprises. So that is what we have. If you start including these uncertainties, then perhaps it is fair to say that climate change is not as bad as losing 1 year of economic growth, but a century of climate change is perhaps as bad as losing 10 years, a decade of economic growth. Still, that is not the biggest problem of humankind. The Japanese have lost 30 years of economic growth by now and still seem to be a relatively content and relatively happy society. So this is where we are. What is wrong with these studies? The assessment is still incomplete. There's still things that impacts of climate change that we know about that have not been included. And perhaps the biggest of them is the impact of climate change on tourism and recreation. Simply not in there in any of the estimates that I showed. Interactions between impacts are ignored in a number of studies, particularly the enumerative studies that I mentioned, where people estimate the impact of climate change on agriculture, and they estimate the impact of climate change on water resources, and completely ignore that about 80% of fresh water is used in agriculture. That is something that is unfortunate in these impact estimates. Many of the studies use fairly stylized assumptions about adaptation, and two extremes. One I talked about already. It's the Don Farmer assumption, assuming that people will not change their behavior at all, even if the climate changes. And the other assumption that is mathematically easy to handle is the assumption that people have perfect information about the future climate, and that markets are perfect, and so on and so forth, and we go for efficient adaptation. Of course, reality will somewhere lie messily in the middle. So that is an important shortcoming. Another thing that is wrong with these studies is that the focus is very much on what happens in the middle of the distribution. The focus is very much on trying to get a best guess of the impact of climate change, with very little attention to things that are unlikely, but if they would happen, would actually have a dramatic impact. One of the things that is very current is that the permafrost is melting. There's large areas up in Canada and Siberia, places like that, where the ground is permanently frozen. And if it gets warmer, it gets unfrozen. Now that creates problems for buildings that are put up there, assuming that the ground is always frozen, so there's no proper foundations, and if the permafrost then starts melting, then the building collapses. The same is true for oil pipelines, the same is true for all sorts of other infrastructure that is built there. Now, there isn't a whole lot out there, so this is not a big economic problem. However, in the permafrost, frozen in the permafrost, are also lots and lots of bacteria and lots of viruses that have been frozen and have been frozen for a long time, and they are now being re-released into nature. And most of them will be innocent, and most of them will do no harm to humans at all. They may not even survive being unfrozen, or may not even survive the new competition that they will face. But there is a chance that one of those viruses that are coming unstuck at the moment will cause the next pandemic, or may even cause a worse pandemic than we currently see. That is not included in these studies, and that may be a pretty bad underestimate of the impact. Indirect impacts are not in there. Most of these studies sort of look at climate changes, and these are the first order impacts, and that's it. Later on, I'll talk about impacts of climate change and economic growth, one of the indirect impacts. Another thing that is not in there, that is related to the low probability, high impact. The methods that are used for studying the impact are really methods that are designed to look at small changes, to look at marginal changes. But I showed you this picture of complete changes of the biome. Those things are hard to value, but also actually hard to fathom. What would the world look like if the Brazilian rainforest is replaced with the Brazilian savanna? It would just be a completely different world, and it's just hard to imagine what that would be, and therefore people have not really estimated the impacts of these things happening. So there's lots of things wrong with these studies, but this is all we have, and this is the information, the only information that we can use to look at the economic impact of climate change.